All right, so our lesson 2 homework video, more antiderivatives. We talk about the antiderivative of e to the x, which is e to the x, how the power rule does not work for 1 over x, because we remember that the derivative of log x is has a derivative of 1 over x. We have to be careful, though, because I could plug in any value for x here except for 0, which is why we're going to need absolute x, and then plus a c. So these were our first 2 integrals that we talked about. We also talked about if we had a very easy composition going on, where we have f of ax plus b, that we'll have the antiderivative will just like be the antiderivative of everything. You know, leave the inside alone, antiderivative of the outside. But because of the chain rule, when I take the derivative of this big F, I'd have regular f of ax plus b times a, I need a 1 over a in front of it. It's a whole multiplied by the reciprocal idea that we use with the power rule. Like for these 3, you know, first I have log x, absolute x. But then for the other ones, x to the negative second, this is x to the negative third, I have to use the power rule, and it's like add 1 to the power, multiply by the reciprocal of the power in that order. That's the whole idea with this. So add 1, multiply by the reciprocal, then maybe rewrite. So I get log of absolute x plus negative 1 over x plus negative 1 over 2x squared plus c. Okay? And here is the first example of that. The antiderivative of e to the x is e to the x, so I'm going to have the e to the negative x. But then I need the reciprocal. Now I have just a negative 1 here, so there's no reciprocal, but the antiderivative of e to the negative x is actually the same as the derivative of e to the x, e to the negative x. E to the x, e to the x, this is a tricky one. E is a constant. If I told you to take the antiderivative of 3, you'd say, oh yeah, obviously, 3x plus a c. Well, e, its antiderivative is ex plus a c. Okay, so be careful with that. If I have constants here, this 3 over x, this 4 over 5x, just don't worry about it. We could write this as 3 times 1 over x plus 4/5 times 1 over x. So this should not worry you. And again, the constant multiple rule for antiderivatives would be the constant times the antiderivative, the constant times the antiderivative, and we're good. That looks a little nicer. Okay, now we're getting into the whole antiderivative of f of ax plus b. So e to the 3x. I'll have e to the 3x, but I need the reciprocal of the coefficient of x. Okay, think about taking the derivative of this. It'd be e to the 3x times 3. The 3 and the 1/3 cancel. 2 cosine 4x. Well, antiderivative of cosine is positive sine. So I have 2 sine 4x, but then I know I need a 1/4. Now you can put it in front, you can put it behind, it doesn't matter. Because when I take the derivative of sine 4x, it'd be cos 4x times 4. The 1/4 and the 4 will cancel. Here, if I take the antiderivative of stuff to the 4th power, it'd be 5th times 1/5. But then I need another 1/5 from this 5. So this comes from the 4. This comes from the 5. That's a little tricky. I didn't love this. I don't love this example. I kind of prefer if this was like a 3. Let me just change it really quickly. Well, no, I'll keep it up, but for emphasis, I will do a different one for you. This 1/5 comes from here. This 1/5 comes from here. Another example, integral of, let's do 3x plus 2 to the 4th. It would be 3x plus 2 to the 5th times 1/5, but then I need a 1/3. If I took the derivative of this with the chain rule, I'd have 5 stuff to the 4th times 3. The 3 and the 1/3 will cancel. Now, rewriting this, simplifying this a little bit, I'd have 1/3 e to the 3x. Can't do anything there. This becomes 1/2 sine 4x. That's good. This becomes 1/25 5x plus 2 to the fifth. Okay. Because I just have x to the first power, the antiderivative of this is log. But if I took the derivative of this, I'd have 1 over 2x plus 3 times the derivative of the inside 2. So to get rid of that 2, I need to multiply by the reciprocal of the coefficient of x. So that's why I need a 1/2 here. Then 4 over 5 root x, understand you could have it 4 times 1 over 5 minus x. Rewrite it as that so that you know it's 4 log absolute 5 minus x. But since I have this negative x, I need to multiply by the reciprocal of that. Again, 1/2 log 2x plus 3 plus negative 4 log 5 minus x. There are some log properties you can use to simplify this sum. I'm not going to stress you out about them. But recall, if I have the log of a plus the log of b, since they actually work like exponents, it's the log of a times b. So also if I have a k in front of this, you can bring it up as a power. So I'm not going to get into it. I don't want to stress you out. They're not going to be that important for right now. Okay, find f given f prime. So this is just the same stuff. Of e to the power is the antiderivative of e to the power. So I need a 1/3 here. I got 2 sine. I'll need a 1/4. Don't forget your plus c. Did I include plus c's everywhere? Oh my goodness, Mr. Master. What am I doing? Amateur hour over here. Oh, there's a plus c. Oh, there's a plus c. There's plus c. There's plus c. Okay, good. Let's rewrite this a little bit. All right, these are great ones. To be able to do this, we are not going to use logs. Logs only work for x to the first in the denominator. Instead, we can use the power rule. Take the antiderivative of the outside, it'd be 2x plus 3 to the negative first times negative 1. Don't forget to multiply by the coefficient of x from the inside. So I need a 1/2 there. Here, take the antiderivative of the outside of 4. 5 minus x to the negative second. I'll need a negative 1/2. I also need a negative 1 from this x, reciprocal of the coefficient of x. Don't forget to plus c. And let's just rewrite this. I'll have negative 1 over 2 times 2x plus 3. I could distribute that if I wanted to. Plus, then it'd be positive 2 over 5 minus x squared. Plus a c. Big quotient. Remember to divide all of these by x squared. So if x to the negative second, I'll have 2x to the negative first, I'll have 3, and I'll have 4x. Now watch how I wrote 2x to the negative first. If you use the power rule again, you'll see 2x to the 0 times 1 over 0. That doesn't work. You got to remember with x to the negative first, its antiderivative is log absolute. So let's go to f. X to the negative first times negative 1 for x squared. This will be 2 log absolute x. 3x. This will be 2x squared. Maybe rewrite this as negative 1 over x. Oh, good ones. we got to remember the derivative of a to the x. If we don't remember the derivative of a to the x, we have no shot. We don't use it much. We don't see it much. We'll see it occasionally. So the derivative of a to the x is a to the x log a. So antiderivative to the x would be 2 to the x times 1 over log 2. Why is that? Because if I took the derivative, I need a log 2 to cancel with this log 2. So we like to write it like this, or 2 to the x over log 2. It's not something you have to have memorized. This you have to have memorized and then understand why you need this. And that, and that. Okay? And a plus c. Review. Okay, cool. Find f prime at the value. So we're actually taking derivatives here. So outside, insides, just like to confirm. Might as well give us some space and do this. Since we're taking derivatives, I can use the chain rule. This is like confirming why we need these reciprocal of the coefficient of things. I got e to the power times 3x is derivative, which is 3. And then here for the log outside 3x minus 2, inside the derivative of log 1 over, derivative of 3x minus 2, 3. So this is confirming why we need this reciprocal. If I took the antiderivative of this, I'll do that as well. I wouldn't take the antiderivative of this. I'd take the antiderivative of that. So going from here to f, I'll show you. You would do e to the 3x times 3, but then this would give me the 1/3. Boom. And then I'd have a 3 log absolute 3x minus 2, but from this, I'd get another 1/3. This is why the 1/3 and 3's cancel. This is why you got that. Didn't ask you to do that, but just throwing that out there. We didn't answer the question. We're trying to find f prime of 2, so let's go ahead and do that. 3 e to the 6 plus 6 minus 2 is 4, 3/4 plus some c. What am I doing with plus c's? I'm taking derivatives. This is ridiculous. All right. Outsides, insides. This is kind of confirming why we need that reciprocal of the coefficient of x. Oops. At 0, I get e to the 0 times 2 plus cos 0 times 4 plus e to the 0 times 0. This will be 2 plus 4, which is 6. Quick little review. Didn't hurt anybody. All right, that confirms like why we need the 1/3 when we take antiderivatives. Because we have this chain rule, throws these numbers out there. We're ready to solve some differential equations. We only have, looks like 8, so let's crack to it. So, solving a differential equation means find f. What is f of x equal to? What's the particular solution? So I got 4e to the power is the antiderivative of e to the power, but then I need a 1/3, which is the reciprocal of the coefficient of x. I got x squared plus a c. Told that f of 2 equals 4, so I got 4e to the 0 times 1/3 plus 4, which is 2 squared plus c equals 4. So I get 4/3 plus 4 plus c equals 4. I'll get c is equal to negative 4/3. That's nice. So here's my solution. 4e to the 3x minus 6 times 1/3, so that's 4/3 plus x squared minus 4/3. Excuse me. Cos 2x, antiderivative, sine 2x times a half plus c f of pi over 2, 5 sine pi over 2 times 2 is pi. I don't know what the sine of pi is. I do know it's 0. All right, well, that makes things easy. C is 3, and that is my solution. 5/2 sine 2x plus 3. All right, next one. All right, I got f. 4 log 3 minus x times negative 1 plus c is f of x. I needed the negative 1 because it's the reciprocal of the coefficient of x, and this f of ax plus b. F of 2, 4 log 1 times negative 1 plus c equals negative 2. Log of 1 is 0. I need to know that. 4, this would be negative 4 log e to the 0. That's 0 plus c equals negative 2. c is equal to negative 2. So f of x is equal to negative 4 log 3 minus x minus 2. Ooh, same problem, different initial value. So f of x is 4 negative 4 log absolute 3 minus x plus c. F of 3 minus e. So that's negative 4 log absolute 3 minus, in parentheses, 3 minus e. Why parentheses? Because it's very important. That should equal 5. This is a negative, this is a positive. This turns into 4 log absolute e plus c. We know that the log of e is 1. C is 9. So f of x for this situation is negative 4 log 3 minus x plus 9. 4 more. Second order. F prime e to the negative 2x times negative 1/2 plus 2x plus c. F prime of 0, which is negative 1/2 e to the 0 plus c is 1, means c, negative 1/2 plus c is 1. C is going to equal 3/2. So f prime is negative 1/2 e to the negative 2x plus 2x plus 3/2. Antiderivative of this to get f would be, again, e to the negative 2x, but then times negative 1/2 makes it a positive 1/4 plus x squared plus 3/2 x plus c. F of 0, which is 1/4 e to the 0 plus c is 2. C will equal 8/4 minus 1/4, which is 7/4, giving me my solution f of x equals 1/4 e to the negative 2x plus x squared plus 3/2 x plus 7/4. F prime, negative cos 3x is the antiderivative of sine, but times a third. Don't forget a plus c. F prime of 0 is negative 1/3 cosine 0 plus c. That equals 2. Cosine of 0 is 1. Add a third to 6/3. I get c is 7/3. So this is f prime, negative 1/3 cos 3x plus 7/3. F, therefore, would have to be, okay, the antiderivative of negative cosine would be negative sine. So I got negative 1/3 sine 3x. But again, I need another 1/3 plus 7/3 x plus c. F of 0 is 3. So f of 0, which is negative 1/9 sine 0 plus c equals 3. C, thankfully, is equal to 3. So my solution is f of x equals negative 1/9 sine 3x plus 7/3 x plus 3. Oh, 4 more. I can do it in 10 minutes. Here we go. F. So I'm going to have 2x minus 3 to the 5th times 1/5. But then I need a 1/2. Don't forget a plus c. F of 1. That'd be 1/5 negative 1 to the 5th times a half plus c. That equals negative 3. So negative 1/10 subtracted from 30/10 is negative 31/10. Great. So f of x is equal to 1/10 2x minus 3 to the 5th minus 31/10 f of 2, not that bad, is 1/10 minus 31/10, because this is 1 to the 5th, which is minus 30/10, which is minus 3. Cool. F. 1/2 e to the 2x minus 4. It's e to the 2x minus 4, but you need the 1/2, the reciprocal of the coefficient of x. Plus a c, f of 2 is 4. So 8/2 minus a half is 7/2. F of x is 1/2 e to the 2x minus 4 plus 7/2. F of 3 is 1/2 e squared plus 7/2. F of x, 2 to the x over log 2. Okay. Plus c. F of 0 is log 2. So I got 2 to the log 2. Unfortunately, that's not 1. Oh, gosh, what am I doing? F of 0 is log 2. I was like thinking ahead. 2 to the 0 over log 2 plus c equals log 2. So, one over log 2 plus c equals log 2. I could give this a common denominator. Oh, this is going to work out a little nicer. It doesn't. Whatever, I'm going to leave it like this. Don't care. I get 2 to the x over log 2 plus log 2 minus 1 over log 2. F of 1. 2 over log 2 plus log 2 minus 1 over log 2. That's 2 minus 1 over log 2. I mean, let me see. If I multiply this by log 2 over log 2, I'd get log 2 squared minus 1 over log 2. That doesn't help me at all. Yeah, that's what I thought. Not a great problem designed by Mr. Messner. Let's just go ahead and say that. That's the answer. All right. F of x. We'd have negative cosine pi x. I need a 1 over pi. Great question. You'll see this in the future. f of 0 is 4. So I get negative cosine 0 times 1 over pi plus c equals 4. Not great, actually. Because I get negative 1 over pi plus c is equal to 4. So c is equal to 4 plus 1 over pi. So f of x is equal to, works out fine. Negative 1 over pi cos pi x plus 4 plus 1 over pi, f of 1/2 will equal negative 1 over pi cosine pi over 2 plus 4 plus 1 over pi. That's 0, so this is 4 plus 1 over pi. All right, we did it. It's a very, very important rule, this antiderivative of f of ax plus b. So please, get it to the point where it's like we understand and know why we need 1 over a when I have f of ax plus b. All right, thanks.